This is my Lab 2 report for magnetic field of a bar magnet. The purpose of today's lab is to measure the distance dependence of the magnetic field due to a small bar magnet. This experiment had two components, an experimental and computational model, which we will go over later in this report. This lab utilizes the Biot-Savart law, which lets us calculate magnetic fields of various objects. Some fundamentals to understand today's lab include some essential formulas. The first one is the equation to calculate the magnetic field of an object, where r represents the distance from the observation point to the source. The second equation is the magnitude of the magnetic field equal to kr to the power of n. We will then utilize the derived equation below it during the experimental portion of our lab to be able to determine the significance of values we found from graphing our experimental data. Finally, it is important to note that the value of mu naught over 4 pi r cubed is 1 times 10 to the negative 7 with its appropriate units. Other things to consider is that the system for this experiment is a magnet, and everything else is considered to be its surroundings. We were then able to perform the experimental portion by using a magnometer map to collect data where the magnet was either on or off axis with the phone. It was found experimentally that the magnetic dipole moment was 6.68, the measured off-axis magnetic field to be 6.49 times 10 to the negative 6t, and n was negative 2.01. After completing the experiment, I inputted the data collected and was able to come up with a graph that models it. In this portion of the lab, we utilized the derived natural log equation for the magnetic field to determine that n is equal to the slope of the graph, hence the negative 2.01 value. Then, to compare the experimental results, I input equations into this code. Here you can see that I am setting up constants and creating the formula for the magnetic field. Then I am setting up arrows for the model that the code will produce and using those arrows to represent the magnetic field. Finally, I coded some more arrows to represent the perpendicular magnetic field. Then I coded an observation point 45 degrees from the axis. Here are the resulting models from the code. Now we will compare the computational model to the experimental. Overall, the computational model resulted in greater values for the magnetic field. The code calculated the magnetic field to be 8.55 times 10 to the negative 6t for the x component, whereas when calculated through a formula, the x component is 6.49 times 10 to the negative 6t. So what if we hadn't oriented the experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? Our x component of the magnetic field had a magnitude of 0. The final x component would depend on the magnometer's initial orientation. And what if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? Our magnitude field values would increase in magnitude. Thank you.